So compression is one of the tools that is like one of the central tools that you use when you're mixing a track. And alongside EQ and reverb and panning and things like that, it's kind of the most complex out of those tools. But that doesn't mean that it's actually that complex. So it's one of those things that you can use for a long time and maybe not fully understand what it's doing. And it can be kind of helpful to fully understand it so that you can be a little bit more specific about how you use it. I definitely was using it for a long time before I actually thought, okay, wait, how does this work? So that's kind of the idea. We'll look a little behind the scenes how it works and just ask questions. And if you need an example to be more relevant, ask for that. In general, we talk about it as something that decreases dynamic range, which just means the difference between the loudest and the less loud parts of a sound wave. So I want to show just like a quick example. We put some very heavy compression on this waveform. And if we are to flatten this, this is what it looks like. That's the same clip, but with way too much compression on it. So you notice that because we had our makeup gain on, it made everything louder, but it also reduced the difference between the quiet parts and the loud part. Everything is just super thick right now. So the idea is that one of the uses for compression is just to make a sound thicker. And that means that even if you don't make it louder, it sounds louder to the ear because there's less variation. You just have more peaks, higher peaks in general. So that's just a visual example of that. I think we can go ahead and take a sample I got from Splice. This is not an ad for Splice. So let's check this out. I'm going to loop it with Command L. And if we take a look at this vocal and maybe take a listen.
Tell me if you're nice. Oh yeah, tell me.
The first thing you'll notice, yes, thank you for the cheerleading, is obviously this part right here is quite a lot louder than the beginning and the end. Like we just have this part that's much louder. This happens normally when you record a singer or a live instrument. Like parts of it are just sung or played louder, or they're closer or further from the microphone. So this is totally normal, although it's exaggerated for this example. So one thing that you might do is just go into the volume and automate the volume. For this part, if we were to just drag this down, then effectively we reduce the dynamic range. So we're starting real simple just to illustrate the concept.
Tell me if you're nice. Oh yeah.
But if I have these vocals across a whole track, I don't want to go through and automate the volume on every single phrase and peak that goes a little bit above the average level that I want. I want to spend that time just really, designing the feel of the track and placing this in the mix. So that's essentially the job of the compressor. It'll come in here and automate your levels for you. So that's it in a nutshell, but we're going to dive into like parameter by parameter and see how we can be specific about how exactly we do that. I'm going to turn off makeup gain. We're going to look at that in a second too. This is the Ableton compressor, just comes stock with the DAW, and we're going to look at the basic parameters, all the knobs and whistles that are going to be pretty much the same in any compressor, in any DAW. There will be a couple of Ableton specific things that we'll call out, but for the most part, these concepts will transfer to other compressors. The first thing that maybe is Ableton specific that I'll call out is the views. This is called the collapse view that shows our levels just in bars. This one is the transfer curve, which shows the speed of the compression being applied. And then this is the activity view, which is pretty good for getting getting a visual of the compression that we're actually doing on the sound. So first parameter we're going to look at is the threshold. And when we look at, let's actually take a peek at let's turn this off and look at our sample playing in the mixer view or the session view and get an idea of the levels.
Tell me if you're nice. Oh yeah.
So it's kind of averaging around -24 for the quiet parts and -12 decibels for the louder parts. So the first thing we want to do is we want to set our level at maybe close to what the quiet parts are. I'm going to say -23, 24 decibels. So that means everything that's above this threshold is going to get compressed. Now we still have time to control how hard it gets compressed, how fast it gets compressed, the quality of that compression, etc. But the first thing you want to do is say, you know, where's the literal threshold? Anything above this value will be affected. So as soon as a sound wave comes into this compressor that is louder than -23 decibels, the compressor gets activated. Okay, so that's threshold. Pretty simple, right? The next thing to understand is ratio, which is also pretty simple. The ratio is any amount of sound that comes in above this threshold. If it's set at 2:1, then we're going to cut it in half. This is literally a ratio of decibels in to decibels out. If we get 2 decibels above 23, then we're going to only output 1 decibel. So a good way to visualize this is to kind of see it. If it's at 1:1, then there's no compression.
Tell me if you're nice.
It makes no difference. This middle bar is the gain reduction. That's what the GR stands for. So you notice there's no activity there if we're at 1:1. So you can go anywhere from 1:1 to infinity. With infinity, it cuts everything down to your threshold. The best way to visualize that is if we were to, let's say, duplicate this and freeze it, or we could just record it into a new track, either way. But so this is what our waveform looks like now that we've cut it down just straight to -23. And if you look closely at the waveform, you can see a lot of horizontal line. And so that's kind of not good, because that means that even if it's not that noticeable in this context, then we've erased a whole bunch of detail and like timbre and character of the sound. So the levels are good, but we kind of took away a lot of the fidelity of the actual sample. So this is not how we want to compress. That's called limiting. In fact, that's a limiter is just a compressor with the ratio all the way up. So the range that you'll tend to be in is somewhere between, say, 3 and 10, but it's going to vary based on your ears and the situation. But essentially, it's just the higher the first number is, the greater the gain reduction is. And that's as simple as that. So for our example, we have our threshold at -24. Anything that comes in should be reduced a little bit closer to where that level is. So right now we know that the difference is about 12 decibels. So we can come maybe a little bit closer to that. Now let's watch an example.
Nice, nice. Oh yeah, tell me if you're nice. Oh yeah.
Okay, so there you can see that it is bringing down the volume whenever we get to that peak, but it's still not exactly as we want it to be. So let's talk about a couple of the other parameters here. Now, if threshold says when does the compressor turn on, and ratio says by how much do I reduce the gain of things over the threshold, then attack says at what point once I hear the transient cross the threshold do I actually start compressing. So if this was set to 0, then as soon as the wave peaked above our level, we start compressing, which would probably be the kind of thing we would do for this type of sample.
Nice. Oh yeah, tell me if you're nice.
But if I were to make this longer, let's watch it visually, what happens.
Nice. Oh yeah, tell me if you're nice. Oh yeah.
So it doesn't start right when the peak hits. It starts right after it. I mean, this is by hardly any time. That's what we're telling you. We're saying, do we want to hear that transient before we start compressing, or do we not want to hear that transient? In this case, we don't really want to hear the peak before we start compressing it. So we're also going to look at a quick example of a percussive sound and how we might use this to our advantage if we do want to hear that transient differently. So keep that in mind. Next parameter we can look at is release. So, and if you're doing any type of audio production, you already recognize these terms, attack and release. So release is once we have reduced the gain down by the ratio that we said, after the attack time, after the thing crosses the threshold, then how long does it take to open that compressor back up and stop reducing the volume? So I think a good way to illustrate this is just first of all, put it at way too long and see what it does.
Nice. Oh yeah, tell me if you're nice. Oh yeah, tell me if you're nice.
So what you're seeing is it's not even opening back up by the time the clip goes in a loop. This is what you want to think about when you're setting the release for a continuous sound. You want to think about, first of all, like, what is the appropriate amount of time? Like how long are the peaks that I actually want to turn down? Because if it's too long, then you're going to be just compressing everything after that point until the release is over. So what we've done so far is we said, all right, this is threshold. As soon as you cross that threshold, I'm going to wait for the attack time. And then once we've waited for that attack time to pass, I'm going to reduce by this ratio. And then once I've reduced by that ratio, I'm going to wait the release time and then stop reducing. So that's the whole thing. So any feedback or questions where we are right now?
I think like just my biggest struggle with the Ableton compressor is like pressing buttons and then listening and not being able to hear if I'm really hearing a difference or not.
Mm-hmm. Okay. Yeah, I know exactly what you mean. It can be really, really subtle. So actually what I recommend doing is starting with very exaggerated parameters and then drawing it back down toward subtle so that you can really hear the difference. So that's like we just saw with, look at this release, you clearly could hear that it was turning down the whole clip for 3 seconds. So as we draw this in, we can start to hear, okay, it's coming back into reasonable length. But I agree, I think it is actually subtle. It can be subtle, and that subtlety can be good, but it can also make it difficult to get comfortable with making these changes. So just takes some getting used to, really. There's a funny thing about release also. It's like if we have a percussive sample, then you're going to definitely want to make sure that your release is less than the amount of time between the percussive samples so that you're not affecting transients unevenly. So something to pay attention to. And yet, because all samples have a unique sound wave, there isn't just like a magic number that you can put it at for the BPM or anything like that, unfortunately. So it's something that you'll play with. You'll maybe start it really high and start bringing it down until it makes more sense. So let's do that with this sample.
Tell me if you're nice. Oh yeah, 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 tell me if you're nice.
Okay.
Oh yeah.
So this, we can see basically what we're seeing is like the inverted line of the actual sound wave that's coming through. That's what we see in the reduction for the louder parts. And that's what we want. We basically want, if we're trying to get consistent levels, then we want to see the reduction happening at the same rate that the peaks are happening in audio. So there's that. And then there's one more detail and like level of granularity for the timing of all of this. As you can see, compression is actually a lot about timing. It's all about when things happen. When are we changing what levels? So the last detail here is the knee, which I guess it's called that because it is shaped like your knee. And your knee can be either very sharp or very softly curved. Maybe not your knee on your legs, but this one can. So if we want this to be really sharp, what this means is, so let's go back to the order of things happening here. we cross the threshold, we wait the attack time, and then after we wait the attack time, how quickly do we apply the sound reduction to the ratio that we've specified? So it's another tiny level of granularity that you can get to as far as not only when do we start compressing, but how quickly do we go from this level to that level. So that's what the knee is. If it is at 0, so it's just a point, then it happens quickly. Then as soon as we get to the attack, it's like, all right, boom, we're gonna go to that level that you told us to go to. Sometimes we don't want that. This is just gonna depend on what kind of compression you're applying. So makeup. Makeup is one more parameter that you wanna know about if you're just talking about learning compression in general. So we looked at basically in our example of this, when we flattened it, it brought down the levels of the peaks. What makeup does is it brings down the levels of the peaks, and then it brings the whole thing back up. So this is something where you can make changes to the output yourself here, making it louder or quieter, but this will automatically get it to the same average loudness that it was before you started compressing it. So that can be really handy. We're going to turn that on now.
Tell me if you're nice. Oh yeah.
So now you can hear the whole thing's louder and it's a lot more consistent. So if we were going to do the same thing we did before, but with these settings, this is essentially what we're looking for. Like, we still see definition in between the different parts of the sound here, but it's closer in level and everything just is going to sound louder. The other thing is, when you have an ongoing sound in a track, sometimes doing that compression is going to make the whole thing just sound louder to your ear because it's more consistent. So you start to bring things to a more middle ground level, and then overall, the presence is stronger. Okay, let's check out the chat. Kick snare parts, not smaller instruments like hats. What was that question regarding?
That was just when you were mentioning setting the release time so that it doesn't extend past the initial sound that it's meant to with percussion and take away all the transients. I was thinking about when you're compressing a whole percussion part, like a whole kit maybe.
Yeah, totally. So when we're talking about compression on percussion, there's usually going to be 2 levels of it that you do at least. So you might compress each sound. So like you said, kick, snare, you're going to add percussion to shape those how you want them. And then you also, the third use of compression is what's called glue. So you'll put that on something that may contain a variety of sounds like percussion, like a whole drum bus, and it'll give you a consistent level throughout, bringing everything closer together. And so in that case, yeah, you don't think of release exactly the same way. You just think of it in terms of how it relates to the other elements in the track, which can sometimes mean you're compressing your hi-hats in relation to the other percussive elements, or maybe you sidechain them, which we'll look at sidechaining for a second too. But yeah, I think that's a good point. Like, you may add compression on your hats, but you may also add a layer of compression on your group of percussion where you think about release a little bit differently. The other thing I want to do is just take a quick look at a very boxy kick sample and talk about the concept of using compression to sculpt a sound. All right, so here we go. Here's our big boxy kick. Let's give it a listen. That was loud. If anybody needs to turn your volume down, you can do that. Okay, so that's our kick. It sounds pretty boxy. It's just a big thud, really. So let's go ahead and add a compressor. And we'll do the same thing. We'll take a look at, we'll turn off the makeup again, take a look at the activity view. We'll set our threshold according to the levels that we're seeing and everything we just did, but we'll do a couple things differently. So we're going to say, okay, well, I think my kick should be around -12 dB. So anything over that, we're going to start to reduce. We're going to turn down these all the way. And we see that the gain reduction happens right away. Oh, I see what I did. Okay, let's change this loop a little. So one thing that we're often looking for in a kick is, in addition to just the bass presence, we also want that snap at the beginning. And there are a lot of ways to go about getting that. A lot of times people have compound instruments for kicks. We have like our sine wave and we have our snap. But if you have a kick, you got a sample from somewhere and you want it to be more snappy, then that might mean that you're going to take down the volume after the transient. And so the transient, of course, is just the point at which the audio peaks in volume. So we might say, all right, let's start looking closely at this and say, how long do we want to let this wave play before we start taking down the volume? And so we'll play with the attack time on that. Well, let's say we put it at 1 first. That's just taking the whole thing down as soon as it peaks. We move it forward a little bit and let's see what happens. So let's do a A/B test here. So you can clearly hear the difference here. If we offset it by a little bit longer, then you get this crunchy sound up front, and then it pinches down the wave after that. So that's what we're doing with the attack. With the release, we can also, let's say we want it to have a sort of follow-up thud sound. We want it to be snap and then thud to the ear. We could make the release really short, a little bit longer than the attack, so it reduces it and then lets it back out. But you see how you can start to use these tools to really shape the sound and kind of like where the volume peaks and is reduced over time as the sound plays. So that was a quick little demo I wanted to give on that. One last thing that I want to look at, and then we'll be done with our, talking part of the meetup, is of course doing a little side chaining. So I'm doing Option drag to just copy this thing across, and then I'm going to go back and re-enable our vocal and do Command L to loop it. The last thing we'll do is we'll look at sidechaining. Now, I want to contextualize this. I think everybody maybe has heard of sidechaining, maybe some people haven't, but just to put this in context with what we've been talking about, sidechaining means that when I set my threshold, it's not going to look for this sound wave to reach that level. It's going to look for the input to reach that level. So if I say sidechain from the kick, which is now called kick thud, then that means that whenever this sample reaches a threshold, then I compress this sample. Okay, so that's really the only difference. A lot of times what you'll hear is people using this stylistically to sort of like create a pumping sound. And so it's often used on basses. If you do a high ratio and a quick attack and a medium release, then you'll get that sort of like ducking sound. So like the sample that you're compressing completely mutes when the transient of the kick happens, but then it comes back up at whatever your release is set at. Let's do a little sample here.
Tell me if you're nice. Oh yeah, tell me if you're nice. Oh yeah, tell me if you're nice. Oh yeah.
So you can clearly hear it's sort of pumping and it's ducking out every time the kick would be hitting. So that is another very, very handy thing for especially getting like bass elements to sit well together, is maybe one of them sidechains to another. And I think it's pretty common practice, but I did want to put it in context of the only difference is and we can also look at it here. This is probably a good time for a visual.
Tell me if you're nice. Oh yeah, tell me if you're nice.
So our compressor is looking at the peaks of the kick, even though it's applying its compression to the vocal sample. I think that's it as far as actually, covering the basics of using compression for like making something sound louder overall, leveling out, and for sculpting a sound. So these are all the parameters that you need to start exploring that in detail. So anybody want to like dive into anything or see anything else? Questions, thoughts? Open up.
I'm curious about the sidechaining.
Yeah.
Is I'm really interested in, and I'm just thinking about other applications in terms of just how another view of how to use that to bring maybe. So I'm thinking about like tracks with like a bunch of different instruments going on, right? And if I wanted, say I got like strings and big drums and kicks going on, and I don't know, I wanted a flute to really stand out. Like, is this a case where I would use something like that?
It absolutely could be. So when you're talking about mixing with a whole bunch of different instruments that some of them may be in the same range as each other and one should stand out, definitely compression is an element of that. It's also a matter of like the levels in general. Like maybe you want the other instruments to be quieter when the flute's in. You can sidechain them to the flute, and that's a perfectly reasonable. I mean, obviously there's no laws here. You can do whatever you want. But yes, that is a reasonable use of that. And
well, I think the logical also question that goes with this is sidechaining with the EQ. And I'm assuming you all already did a session on that, and I'm hoping that there's something, there's another session like this on EQ as well.
We actually didn't do that, but that's a good point. So let's say we have a kick that is a kick that's already compressed. So let's go ahead and take this kick back to where it was. Our compressor is on, makeup is on. We're gonna print this. We've all seen what happened, so I'm not gonna try to preserve the history. Ableton will betray me. Anyway, so now we have our kick like this that has a snap to it. Let's look at the EQ for a second, and then let's look at how that fits into using it in your compressor. I just started using the favorites area of Ableton. Yeah, it's handy, but you have to like actually use it. So here's our kick, here's our EQ on the kick. So this is completely a simulation. You're going to design your kick to sound how you want it to sound. Let's say your kick knocks at around here, and you see that because that's kind of where it's speaking your EQ. Well, what I would want to do in order to use that in compression is I turn on sidechain and EQ, and then I tell it here what frequency I want it to pay attention to. So that would mean that only when this frequency region crosses my threshold am I going to respond. So that would mean, okay, it doesn't matter how loud the rest of your kick is, but when I'm only listening for the snap. So whether the snap happens right at the beginning or later in the sound, that's what I'm going to be listening for. And I'm going to tie my timing of my compression to that. So that is basically how that works. You'll go find like what area of the sound you might pull up an EQ like this, which by the way has this beautiful huge view, and kind of look for, where is the presence of this sound, and then you'll go into the sidechained compressor and select for that area and listen to it, and then it's going to behave like all the same other principles apply the same way as far as the gain reduction over time.
I think you just opened up more questions, but good questions. Good things for me to explore now. This is super helpful for me. Thank you.
Awesome. Well, that's what I want to hear.